This is worksheet 9E, exercise 9E from the worksheet, chords of a parabola. If you're not sure which worksheet it is, it's actually this worksheet, which you were given out in class, I think on Monday. Okay, it's on parametric equations. We're going to look at question 5 and 6 now. Okay. Now I will stop the video so that you can try it on your own, and then you just need to watch through the video if you're having problems. So the first question for question 5, it says that P and Q are points with parameters P and Q on the parabola x equals at squared y equals 2at. Now I told you that you would always get parabolas that are concave up, and normally the parameters that we're used to are that we normally see are x equals 2at, y equals at squared. So this is the other way around. So therefore this parabola is the sideways parabola. Okay, so I'm going to draw a sideways parabola because if I make t the subject, now you would make t the subject of this one. So I don't need to do it, but because we can recognize that it is the parabola y squared is 4ax. Okay. But you can do it if you want. I'm not going to do it because we've done it in previous lessons, okay? And you actually don't need to do it for this question. I actually might do it in part B of this question, but. So we've got P and Q are points with parameters P and Q on that parabola. So the point P will be AP squared 2AP. And I'm just going to put the point Q down here. I like to put P and Q on opposite sides of the parabola, and point Q will be AQ squared 2AQ. Now the first question is to show that the chord PQ is that. They're therefore asking for the equation of the chord, okay? So they want the equation of this chord PQ. Remember, if this was just ordinary points, you would find the gradient PQ, and then you would use the point gradient form, where you use the gradient and one of these points. So why don't you pause the video? I want you to do firstly the gradient of PQ, and then do the point gradient formula using that gradient and this point P. Okay, restart the video when you're ready, and hopefully you'll get this here. If you don't, then you can watch the video and copy, and if you do get it, you can fast forward the video to where it finishes that bit. Okay, gradient PQ. Now here are our points P and Q. I'm going to call this x2, y2, x1, y1. It really doesn't matter which way you do it, okay? So let's go. We've got y2 minus y1 over x2 minus x1. So I'll just make sure this is focused. So therefore gradient PQ is 2AP, that's y2 minus y1 is 2AQ. Over x2 is AP squared minus x1 is AQ squared. Now the next thing you need to do is factorize and cancel anything. 2a is a common factor on the numerator, 2a bracket p minus q. On the denominator we've got a as a common factor, p squared minus q squared. Now we can see that the a's cancel, so we get 2 bracket p minus q. P squared minus q squared is a difference of 2 squares, and you get p minus q, p plus q, and therefore the p minus q's cancel, and so therefore the gradient of PQ is 2 over p plus q. Now if you remember back to question 3, that was done for the concave up parabola, and the answer I think that we got was p plus q times a half, which is p plus q on 2. Because this parabola is a sideways parabola, we've got the inverse basically of what we got in question 3 for our gradient. That's why you don't memorize off the formulas for any of these. They will give you the direction in which you need to head, and I'll show that the chord PQ is that. So once you've done the gradient, we can use the point gradient formula, and you will know whether you've got the answer right or not. So my gradient that I'm going to use is 2 over p plus q, and the point that I'm going to use is point P, which is AP squared 2AP. So now we're going to use the point gradient formula, which is y minus y1 equals mx minus x1. So this will be the equation of PQ. And we get y minus 2AP equals m, which is 2 over p plus q, x minus AP squared, because this is x1, y1, and that's the gradient m there. Now, notice that what we're trying to get, there is no denominator, so we need to multiply this other side here, if this is 2 bracket x minus AP squared all over P plus Q, I want to get rid of this divide by P plus Q, so I'll be multiplying the other side by P plus Q. So it's P plus Q times all of this y minus 2AP is equal to 2 bracket x minus AP squared. So I'm taking this P plus Q over to the other side. Just got to be careful because this is more than one term here, so P plus Q needs to be multiplied by all of that. So we've got, do P times each of those, and I've got PY minus 2AP squared plus QY, and this will be minus 2APQ, is equal to, and just expanding this, I've got 2x minus 2AP squared. Now, notice they've taken everything over, I think, to this side over here because the 2x there is positive in what you're trying to prove, and we'll just keep everything on this side. But before I do that, you've got minus AP squareds cancel, and I'm going to take everything over to the right-hand side. So I've got 2x, and then I've got minus PY minus QY plus 2AP equals 0. So I'm just taking all of these over to the other side. So I've got 2x. Now I've got minus y is a common factor here. So minus y, then you'll get P plus Q because we've got minus PY minus QY plus, sorry, I'm off screen. So I've got 2x, then I've got minus y as a common factor for both these terms. Minus y, bracket P plus Q, because that gives me minus PY minus QY, plus this term here, 2AP is 0. And therefore that is exactly the same as what you've been asked to prove up here. So 2x minus P plus QY. So I can just rewrite this as 2x minus P plus Q times y plus 2AP equals 0. And that's part A of question 5. Now we're going to look at part B. Now question 5B, it says, now I'm going to go back to what I had drawn before. This was a sideways parabola, which is y squared equals 4ax. And this was the point P, which is 2AP, AP squared. And this is the point Q, which is 2AQ, AQ squared. Now, we're told that if OP, see O is the vertex of the parabola, okay? So if OP is perpendicular to OQ, show that the x-intercept of PQ, so here's PQ, you have to show that this x-intercept, whatever it is independent of P and Q. So we need to work with this OP is perpendicular to OQ. So when you know that if OP is perpendicular to OQ, the only thing we know with perpendicular lines is about gradients. We know that the gradient of OP times the gradient of OQ equals -1. Okay, so we're going to look at that now. So let's look at what the gradient of OP is. Wouldn't it be y2 minus y1? Remember, O is the point 0, 0. So it would be y2 minus y1 over x2 minus x1. So it would be AP squared minus 0 over 2AP minus 0. So the gradient of OP, I mean, the other thing you can do is just go rise over run, but I'm using the gradient formula. So it's AP squared over 2AP. Notice that the A's cancel and that one of the P's will cancel. And you get that the gradient of OP is P on 2. Now we can do a similar thing for the gradient of OQ, and it will be y2 minus y1 over x2 minus x1. Look, you will get exactly the same thing, but wherever there's a P, you'll now get a Q, because the coordinates of P are 2AP, AP squared, Q is 2AQ, AQ squared. So if you do this same process, which is AQ squared minus 0, which is y2 minus y1, over x2 minus x1, which is 2AQ minus 0, you get AQ squared over 2AQ. And cancelling out the A's and one of the Q's, you get Q over 2, which is what we said we would get. Now, we know that the gradient of OP times the gradient of OQ is -1 because they're perpendicular lines. Therefore, we can say that P over 2 times Q over 2 is -1. That means that PQ over 4 is -1, which means that PQ is -4. Okay, now it says if the gradient of if OP is perpendicular to OQ, show that the x-intercept of PQ is independent of PQ. Now, in part A, we worked out the equation of PQ, so I'm just going to write down what that is. So the equation of the chord PQ, just getting that back, was 2x minus P plus Q times Y plus 2AP is equal to 0. Now, we know from this result, just in part B, that P times Q is -1. Now, when I look at this, I can see that there is no PQ to substitute. So what I'm going to do here is I'm going to rearrange PQ as -1, and I'm going to come up with an expression for Q. So Q would be -4 over P. So now what I want to do is I'm going to substitute Q is -4 over P into the equation above, into the equation of PQ. So I've just written that down there. So substitute Q equals -4 on P into the equation PQ. So I get 2x minus P plus Q, which would be -4 on P, Y, plus 2AP equals 0. Now I'm going to expand that, and I've got 2x minus PY minus 4y over P plus 2AP equals 0. Now, having, this isn't really getting me anywhere yet, just going to see what we can do. Okay, have just worked out what it is. And I should have probably just done it up here instead of expanding, but that's okay. The question is asking me, show that the x-intercept of PQ is independent of P and Q. Now we know that for x-intercept, so to find x-intercept, so for x-intercept we substitute y equals 0, okay? And if we put that in, like we can put it in up here or put it in down there, we get 2x minus 0 minus 0. So 2x plus 2AP equals 0. I'm going to divide through by 2. So divide through by 2, and I will get x plus AP equals 0. And still not done yet. Another little mistake. Actually, just transcription error. The equation of PQ, when I just went back and looked at it, and I realise I've written the wrong thing even back here. So going back to question 5, sorry about that. I've got minus 2APQ. I forgot to write the Q there, and the Q there. So just going back to that on the page before, there are Q's here. Now you've probably picked that up already and wondered what I was doing. But yeah, I went from that line. I forgot to put the Q's in. So here, equation back on this sheet, the next page, equation of here, this is a Q there as well. So you can even notice that when you look at your question booklet, okay? So this is a Q there, a Q there, a Q there, and this is a Q here, and that's a Q there, okay? So now we're nearly done. Now we're going to substitute PQ equals -4 from part A, and we get x plus A times -4 is 0, which means that x minus 4a equals 0, which means that x equals 4a. So therefore, the x-intercept, so x-intercept of PQ is 4a, that's the x value, and 0, because we know that for x-intercept here, that it's some x value and y is 0. Remember, we substituted y equals 0 into our equation there, okay? So sorry about that. That was a Q there, Q's all here, which made the substitution for PQ quite easily. So what we would do back here, you can make, so what we really need to do is, we don't need to really do this, okay? You don't need to do this. And you can if you want, but you don't need to. All we needed to do was substitute y equals 0 and PQ equals -4 straight away into this equation here, okay? And if we did that straight away, okay, we would have got 2x minus, this would have been 0, plus 2a times -4 is 0. If we put y is 0 and PQ is -4 straight in here, then we would have got 2x minus 8a is 0, 2x Sorry, now I've come off the screen, sorry. 2x is 8a and x is 8a on 2, which is 4a. Therefore, the x-intercept is 4a0. So, sorry about making that harder than what it should have been, but I just had a transcription error there of the Q. It's really important that you copy things down correctly. So because I knew I got into a dead end here, that's what made me go back and look at it, because I knew it wasn't working. Okay, this is question 6a from worksheet 9e, chords of a parabola. The question is, the line x plus 2y minus 8 equals 0 intersects the parabola x equals 4t, y equals 2t squared. By forming a quadratic in t, find the parameters at the points of intersection. Now, look, I could do a quick sketch. You may recognise this as x equals 2at, y equals at squared. So you may recognise it as x equals 2at, y equals at squared, where a is 2. And we know that it's of the format x squared is 4ay, so the parabola is x squared is 8y. In other words, it's a concave up parabola. I'm just doing this so that you can get an idea of what the question looks like. Look, in the HSC questions, you will have a diagram, okay? So you won't have to do that interpretation, but we know x equals 2at, y equals at squared, a is definitely 2. It's the concave up parabola. So the parabola is x squared is 8y. We're told that this line here intersects that parabola, intersects this parabola, okay? Now, what we're going to do, it says, by forming a quadratic in T, find the parameters at the points of intersection. So look, we know that x equals 4t. Why don't we substitute that in there? And y equals 2t squared. So let's do that. So we've got x plus 2y minus 8 equals 0. That really is the only thing you can do. So we're going to substitute x equals 4t, y equals 2t squared. And by doing that, we will end up with a quadratic equation in t. So we get 4t plus 2 times 2t squared minus 8 equals 0, and we'll get 4t plus 4t squared minus 8 equals 0. Putting the squared term first, we get t squared plus t minus 2 is 0. It says, forming a quadratic in T, find the parameters at the points of intersection. Now look, if I have a quick look at this line, I just want to make y the subject. I would get 2y equals negative x plus 8. In other words, y is negative x on 2 plus 4. In other words, it's got a negative gradient. The y-intercept's 4. The equation, like the line is going to look like that. It's going to cut through 4. It's got a negative gradient, and it's going to cut the parabola in 2 places. So I'm going to solve this quadratic equation. It would be t plus 2t minus 1 is 0. And so we would get t is negative 2 or 1. Now we know that that line intersects this parabola. Okay, so let's just substitute these t values into x is 4t and y is 2t squared. So when t is negative 2, we get that x is 4 times negative 2. In other words, it's negative 8. And y is 2 times negative 2 squared. In other words, y is 2 times 4, which is 8. So when t is negative 2, we've got the point negative 8, 8. And that would be, let's say, this point here, negative 8, 8. And when t is 1, we get that x is 4 times 1, which is 4. And y is 2 times 1 squared, which is 2. Therefore, we're saying, now this is obviously not drawn to scale. This point could be the point 4, 2. I probably should have drawn it a bit flatter like that, but that's okay. All right, so these are our 2 points of intersection. So we've found, well, it's saying find the parameters at the point of intersection. So the parameters at the point of intersection would be t equals negative 2 and t equals 1. These are the parameters. So your solution is t equals negative 2 and 1. But if I actually substitute them into what x is and y, then I actually do find out exactly what the points are, okay, as I have shown you there. All right, now we're going to look at part B of the question. Part B says find the parameters of the points where, so part B says, and I'm just going to write that out down here. It says find the parameters of the points where the line y equals 3 minus x intersects x equals 2t and y equals t squared. Okay, so girls, this is a similar question to what you've just done up above. I'm not going to do it for you, but you can see that this is x equals 2at, y equals at squared. You can see that a is 1. It is a parabola of the type x squared equals 4ay, and where a is 1, so it is the parabola x squared equals 4y. You can draw a concave up parabola, and the line y equals 3 minus x, and the line y equals 3 minus x would cut through it, and you can just follow what I've done up there in part A to work out the parameters of the point where that line intersects that. And you might also want to substitute those t values when you're done into the points x and y to actually work out what these points are, okay? And you can check your answers with the booklet, okay? Question 7 from worksheet 9E. P and Q are points with parameters P and Q on the parabola x equals 2at, y equals at squared. You have to find the equation of chord PQ. Now, we've already done that before in question 3, which was 3 parts A and B. And I think that you also, you did it in question 3 and it was parts A and B. So to find the equation of the chord, you need to identify what your 2 points are, which will be 2AP, AP squared, and 2AQ, AQ squared. Do the gradient of chord PQ and use the point gradient formula. I'm not going to do that here, okay, because we've already done it as an example before. So if you need to, look back at C parts or questions 3A and B, but I do want you to attempt it on your own here again without looking back at 3A and B, and only look back at 3A and B if you can't seem to get it. Of course, check your work first before looking back, okay? Now we'll do part B. Now this is part B. It says, if the chord when extended passes through the point 0, negative a. Now if you look at these parameters, x equals 2at, y equals at squared, you know that it is the parabola x squared equals 4ay. Now it says that the chord when extended passes through the point 0, negative a. Now I want to put that point down here. Now you know that negative a, if this is the parabola x squared equals 4ay, and it is, then we know that the focus is 0a and that the directrix is y equals minus a, which is down here. So before you start putting the points P and Q on your parabola, it says if the chord PQ when extended passes through the point 0a, that chord PQ must actually look something like this. Now I haven't drawn this very well. I'm just going to put P somewhere down here. I'm not sure exactly where it is, and I probably could have this parabola a little bit wider as well. But P is the point 2AP, AP squared, which we know, and Q is the point 2AQ, AQ squared, okay? So for that chord to pass through the point 0, negative a down here, P and Q must be on the same side of the parabola, or they could have been on this side as well and pass through like that, okay? Now it says if the chord when extended passes through 0, negative a, show that PQ is negative 1. Now we know the equation. See, we know at this point that x is 0, so we know that x is 0, y equals negative a, and we can substitute those points into the equation of the chord, because we know the equation of the chord and we know that the chord passes through that point down here through the point 0, negative a. So the only thing you can really do is substitute the point 0, negative a into that equation. So we're going to put y is negative a in here. So you might want to do that now and manipulate the equation, and hopefully you'll get that PQ equals 1. So please pause the video and restart when you're done. So we've got minus a minus a half P plus Q times x is 0 plus APQ is 0. So this all wipes out to 0 and I get negative a plus APQ is 0. Taking that a over the other side, I get that APQ is a. Dividing through by a, I get that APQ is a. Dividing by a, I get PQ is a on a. In other words, PQ is 1. Okay, so that bit's done. Now we can look at part C. Remember, the other way you could have done this is factorize that. So I could have said, well, that's really the same as APQ minus A is 0. Taking out the A, we get A bracket PQ minus 1 is 0. In other words, A is 0 or PQ minus 1 is 0. In other words, PQ is 1. Now, we did look at something similar to that before, but before PQ was passing through the focus, okay? So the chord PQ is not always a focal chord. It can sometimes pass through the axis of the parabola on the directrix, as it has done here, okay? Now we're going to look at part C. And now in part C, hence if S is the focus of the parabola. Now I'm going to go back up here. Now you'll be able to see the diagram. If S is the focus of the parabola, remember the focus here is the point 0A. So S is the point 0A. So I'm going to come back down here. Actually, I'm going to draw it all down here again. So we've got a parabola. I've got, if S is the focus, now S is the point 0A. We know that the directrix was down here, y equals minus A. Okay, and if S is the focus, it says show that 1 over SP, remember P was roughly here somewhere, and Q was roughly, so here somewhere. So we have to write down the coordinates of P and Q again. I'm just drawing it again. 2AQ, AQ squared, P is 2AP, AP squared. It says show that 1 over SP plus 1 over SQ is equal to 1 over A. So look, really what you can do here, you've got the coordinates of S, so S is the point 0A, P is the point 2AP, AP squared, and Q is the point 2AQ, AQ squared. We want to find the coordinates of SP, sorry, not the coordinates, we want to, the only thing we can do between S and P is find its distance. So we want to find the distance SP. Now, if you can please do that using the formula x2, the distance formula, which is x2 minus x1 squared plus y2 minus y1 squared. Let's do that. This is the point x2, y2, and this is the point x1, y1. And then again, you can find the distance SQ, again, using this as the point x2, y2, and that x1, y1. So please pause the video, find the distances of SP and SQ, and then you want to do 1 over that distance plus 1 over the distance SQ, and just start working with that, manipulating it, and see if you get 1 on A. Okay, so please restart the video, pause the video, try that and restart when you're ready. Okay, so SP is x2 minus x1 all squared, which is 2AP minus 0 squared, plus y2 minus y1 is AP squared minus A squared. Now, looks like we've got a bit of work here to do. You need to square that. We've done some distances like this before. So you get the square root of, now 2AP squared is 4A squared P squared, plus this is a perfect square, so please make sure that you expand it correctly. You will get A squared P to the 4 minus 2 times A squared P squared plus A squared. Again, we're going to collect like terms. Now look, we don't want to end up with square roots when we come and do this. So we're hoping that we're going to be able to collect some like terms, that we're going to end up with a perfect square. This is very similar now to what was done in, I think it was question 4 earlier. I'm just going to have a look. Yes, actually, it is identical to what was done in question 4b. So please refer back to that. If you want, just stop here, try it on your own, refer back to question 4b. You're going to get a distance SP. When we come to do the distance SQ, I would not do this all again. Once you get SP, because P and Q are the same, just with parameters P and then parameters Q, once you get what SP is, and we're going to get here, for example, we're going to get A squared P4, I'm just putting that one first, plus 2A squared P squared plus A squared. Remember, we can factor out the A squared. We get A squared, and we get P4 plus 2P squared plus 1. Again, we get A squared. I'm still keeping it together. Remember, this is a perfect square. P squared plus 1 squared. Now, the square root of that would be remember, this is the square root of A squared times the square root of this 1 squared. You would get A bracket P plus 1. So therefore, we've got that SP is A bracket P plus 1. Then you just write similarly, you don't do it all over again. You would get that SQ is A bracket Q plus 1. Now, we did do this again in question 4C earlier on and got the same thing. You do not waste your time in an exam. Sorry, I'm all out of focus. You do not waste your time in an exam. Once you've done SP is that, you can just write similarly SQ is that, because it's just the P's replaced with Q's here. So you're going to get exactly the same answer, just a Q where the P happens to be. So now we need to look at 1 over SP plus 1 over SQ and see what we get, okay? Okay, going over the page and up here. Now we've got 1 over SP plus 1 over SQ is 1 over A bracket P plus 1 over A bracket Q plus 1. Now, obviously, we want to form a common denominator. So the denominator that you would want to form is A bracket P plus 1, Q plus 1, okay? So what are we missing over here? We're just missing... So basically this fraction is being multiplied by Q plus 1 over Q plus 1. So we've got Q plus 1 here, plus this fraction here is missing a P plus 1. So what we've got here is on the numerator P plus Q plus 2 over A. Now it doesn't look like we're going to get 1 on A at the moment, but let's just see what we get. We get A, we get PQ, expanding this, plus P. So we've got PQ plus P plus Q plus 1. Now, actually we might, okay, now it appears that we've come to a dead end. So what you need to do is go back and look at what you've done in earlier parts. And in an earlier part, part A, you were asked to say, you were told if the chord when extended passes through the point 0, negative A. And this is still the same question. Show that PQ equals 1. So we know that PQ equals 1. So we're stuck here and we've got this PQ equals 1. So now what we're going to do is we're going to substitute PQ equals 1 into that equation above, into that equation. And we get that P plus Q plus 2. So we've still got the same thing. 1 over SP plus 1 over SQ is all of that over A bracket. Now PQ is 1 plus P plus Q plus 1. So we get P plus Q plus 2 over A bracket. This is P plus Q plus 2. Now, this is one term up here, and this is another. The P plus Q plus 2 can cancel from the top and the bottom, leaving 1's in their place, and therefore you get 1 over A. And so therefore we've proven what we've set out to prove, that therefore 1 over SP plus 1 over SQ equals 1 on A. So girls, when you do get stuck at points like this, you need to go back to earlier parts of the question, look at what you've proven in earlier parts, and there'll often be a substitution somewhere that you need to make, okay?